In the last episode, we have built a wireless mesh network. If you have followed it, then you should have a configuration like this. A main router connected to the internet. I used the TP-Link Archer C7 for this. A Wi-Fi mesh on the LAN side and a second access point connected to the mesh. For this, I used the Xiaomi Mi Router 4A Gigabit Edition. Both access points serve Wi-Fi in the house with fast roaming. Today, we will see how we can use GRE tunneling over the mesh in order to have an additional guest Wi-Fi and potentially even more Wi-Fis, for example for our IoT devices on both access points over the mesh. In order to separate the guest and LAN traffic, IP routing is just not sufficient. If you are new to this, don't worry for the moment. I'll show everything step by step and also explain why we are doing things the way we do. I have made a couple of videos where we used VLANs in order to segregate the guest, IoT and LAN networks. Please check the links up here if you haven't seen them. But how do we tag or trunk VLANs over the mesh? The Wi-Fi mesh does not support it. One possible solution to do this is tunneling. Rather than tagging the mesh packets directly, we will just encapsulate them into a different protocol point to point and tag them on both ends of that tunnel. What are our options? You may have watched my video about bonding or aggregating multiple VPN interfaces where we actually used OpenWrt TAP interfaces in order to double our internet bandwidth. Well, we could use OpenVPN and TAP interfaces here, but there is also a more lightweight solution to this. The generic Routing Encapsulation or GRE. If you have used VPN connections like 10 or 20 years ago or so, then you might be familiar with PPTP, the point-to-point tunneling protocol. That actually used GRE as well. Again, don't worry too much if you're new to this, it will become clear in a minute. In a nutshell, this is what the configuration will look like at the end of the video. We will have multiple Wi-Fi networks, one for the LAN, one for the guests, and potentially more if you wanted to. Each one of those will have their own IP address range and firewall zone on the main router and will be tunneled over the mesh using GRE TAP devices. On the second access point, they will be assigned to the right Wi-Fi network. Let's start with the first device, my TP-Link Archer C7, which is acting as the main router here. In a first step, I will design the guest interface, then I will add the guest Wi-Fi to it. Let's go. First, I define a new bridge where I will later attach the tunnel devices to. So I click on Network, Interfaces, Devices tab, then Add Device Configuration. The device type is bridge device and the device name is BR-guest. We will add the bridge ports later. Please do tick the box Bring up empty bridge. In the beginning, the bridge will be empty. Just save, then save and apply. Why are we using a bridge for this? The reason is that we later want to link or rather bridge two interfaces together. Our tunneling interface and the guest Wi-Fi. If the guest interface would not be of type bridge, then we would not be able to do that. First, we need to generate the interface which will actually be using this bridge. So we go to the Interfaces tab, where we can see the LAN and the WAN interfaces. Again, I click on Add New Interface. I call the new interface Guest and set the protocol to static address. The device, of course, will be the bridge which I have just created. Perfect. Then we need to define IP addresses and DHCP and firewall options. My LAN is the 192.168.1.x range. So let's just put the guest into the 192.168.4.x range, for example. I'm using the number 4 here instead of 1, but this is just arbitrary. You could choose any private IP address. Let's give it a 24-bit net mask. We do need to fill out the other fields because our default gateway will be the WAN interface, of course. Our guests should be able to browse the internet, just they should not see anything else in my LAN. The next setting is quite important and I miss out on that one so often. Please go to the advanced setting and uncheck the Use Default Gateway top box. As I just said, the only default gateway on this router should be the WAN interface. If we left this box ticked, then the router would try to go to the internet through the guest interface, which totally makes no sense. So untick please. From a firewall perspective, we want this interface to be in its own firewall zone, because we want to be able to define rules that only apply to guests and not to the LAN, for example. So let's just type in the name of the new guest zone here into that custom field. That will create a new firewall zone for us. You need to hit enter here, otherwise the zone will not be created. Next, we want our guest interface to serve IP addresses to guests automatically. So click on Set up DHCP server and just use the default setting for a start. Last but not least, let's adjust the firewall settings for our guests under Network, Firewall. You can see that the new guest zone here has been added down here, but for the moment it has no access to the WAN zone, which ultimately points to the internet. So let's click on Edit, here next to that zone. Scroll down to the field that is labeled Allow Forward to Destination Zones and select the WAN zone. Click on Save. Perfect. So now we have a bridge that is used by the guest interface. The bridge is still empty. We will add our tunnel interface here later. But as we are using a bridge, we can now easily add a Wi-Fi network for our guests and attach it to that bridge. For this, let's go to Network, Wireless. Next to the desired radio interface, I click on Add and define all the Wi-Fi parameters for the guest network. I define a different SSID, such as guest Wi-Fi, a password that is obviously different from my normal Wi-Fi, and also I specify a different mobility domain for fast roaming. Awesome! If you have not clicked Save and Apply in between, then you may as well review all changes by clicking on this Unsaved Changes icon up here and save and apply from there. Perfect! Now we have a guest Wi-Fi in a separate firewall zone on the first router, and we can now start thinking how we tunnel this to the second access point. In order to be able to tunnel over GRE, we need various software packets. So we go to System, Software here, and click on Update Lists to get an up-to-date list of the available packets. If you type -GRE in the filter field, then you will see some of the related packages. The easiest way of getting all we need is to install the Lucy-Proto-GRE package, which will also install all the dependencies, such as the GRE and IP tunnel kernel modules. So let's click on Install. You can see the packets that have been installed on the Install tab. At this point, I rebooted the router to make sure that all modules are loaded and that Lucy would show the new protocol options. Now let's add the endpoint for the tunnel. In order to do this, we will go to Network, Interface, and then click on Add New Interface. Give the interface a name, I called it Trunk. Please do not use long names here, as the interface internally will be called GRE TAP-Trunk, and we may not go over 15 characters here in total. So if we add VLAN tags, then we actually have less than 6 characters free. As a protocol, please use GRE TAP tunnel over IPv4. I'll explain that in a second. Let's click on Create Interface. The remote address would be the IP address of the other mesh node, and the local address would be our own LAN address. On the next tab, that is Advanced Settings, we can and we should bind the tunnel to an existing interface. For the time being, we only have the LAN interface here, which is bridged to the mesh. So let's select LAN as the interface down here. In fact, that means that we will tunnel over the LAN interface. That's not necessarily a really proper setup. we should rather define a new interface and then tunnel the LAN and guest traffic over that separate interface. But we might clean this up later. And for home use, I guess that's okay. Let's choose the LAN interface for the time being. Please tick the box Force Link, as we do want this tunnel always up. I also deselected Don't Fragment because the MTU on this interface is quite low. Furthermore, please untick the box Use Default Gateway. Firewall-wise, we will assign the interface to the LAN zone. That's it. Click on Save. Last but not least, we need to let the guest bridge know about the interface. So let's go back to the network devices and configure our guest bridge and just add the GRE TAP device there. You need to type @trunk.4 into the custom field if you wanted to use VLAN 4 for the guest interface. The @ sign indicates that this is a so-called alias interface. But let me stop here for some explanations. So, why did we use GRE TAP as an interface type here? In fact, a tunnel usually goes from one point to another. It's a point-to-point solution or protocol. The endpoints of that tunnel are ISO layer 3. That means they have IP addresses. But in order to do VLANs, we should have layer 2 interfaces. And that's exactly what a TAP interface does. It encapsulates layer 2 traffic through a layer 3 tunnel. Now, why did we call the interface @trunk.4? The .4 indicates that we want to use a VLAN with the ID 4 over that interface. That's just an arbitrary definition I made for myself. I could have used 33 or 12 or 6 or any other number. But why do I use VLANs at all? Wouldn't it be sufficient to just use the GRE TAP interface alone? Yes, it would. But we would be limited to one network. That means that if we want to add other SSIDs to our Wi-Fi, such as IoT or multimedia or a Wi-Fi for the cameras, then we couldn't do that. If we use VLANs straight away, then we can later add as many interfaces as we want. Cool. Now let's move over to the second node and do the exact same steps over there. That means create an empty bridge, add a Wi-Fi to the bridge, install the GRE software, create the trunk interface, bridge it to the LAN interface. Just this time, of course, the remote IPv4 address is the address of the main router, so 192.168.1.1. Also, of course, we don't have to assign it to a firewall zone, plus the protocol of the guest interface will be DHCP client. If everything went well, then the guest interface should now get an IP address in the guest range from the main router over DHCP. So 192.168.4. something. Perfect. If I wanted to add multiple Wi-Fi networks, such as IoT or one for my cameras, then I would just add an additional bridge and interface like I do here. Just this time, I use a different VLAN ID. I use 3 instead of 4 here. Plus, of course, the interface will have a different IP address range and its own firewall zone. Basically, exactly the same setup like we did in earlier videos, such as the fast roaming video or the video where we added a second access point over 3 VLANs. Just this time we use mesh rather than wires. Awesome! So we have seen how to segregate networks using GRE encapsulation and VLANs over an 802.11s Wi-Fi mesh network. Obviously, this concept has a couple of limitations. As GRE is a point-to-point protocol, but a mesh is rather a network of interconnected nodes, we would in fact need to add a GRE tunnel between our main router and every single access point in the mesh. Probably okay if you have 2 or 3 nodes. But what if you had, let's say, 10 or 10,000 nodes? There are solutions for this, which also bring additional benefits, such as mesh over Ethernet, or rather inter-mesh communication. In the next episode, we will look at one of those, which is called Batman Advanced. So please, do make sure that you either bookmark my channel page in your browser, or even better, subscribe to my channel so that you don't miss the episode. Until then, many thanks for watching, liking, and most importantly, please do leave me a comment and share your experience with all of us. Stay safe, stay healthy. Bye for now.